The Radio Wammo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
It is that time where we like to talk science. The latest science from New Scientist magazine. Janine Young is back now in Melbourne City. Hello to you, Janine.
Good morning, Wammo.
And of course, over the past couple of weeks, we've been chatting to you from all sorts of far-flung places in Europe. Last week, of course, was Paris. The world will be upside down to you now, I'd imagine.
Yes, I'm horribly jet lagged and have been for days, and waking up at 3:30 and not getting back to sleep and wanting to sleep at midday, and I'm all over the place. It's just terrible. Should actually do a spot on jet lag one morning, but no, back to normal. Very happy to be home, back in my house with my kitchen and my bed and all that kind of thing. So it's nice to be home.
And of course, you've effectively done probably enough travel to cover the distance of the circumference of the Earth, no doubt. And I thought today would be a good day to concentrate on planet Earth, and in particular climate change. And whether or not, the first story examines whether or not we can put a price tag on planet Earth.
Well, as an entire planet, no, not really. But there's a bunch of researchers that have been looking at whether or not certain ecosystems and biomes and other, grasslands, rainforests, that kind of thing, can in fact be quantified in what it is that they effectively give back, if you like. Not that they actually need to give anything back, but a study called The Economics of Ecosystems and Biodiversity, TEEB, catchy, has been trying to work out what the monetary values might be to try and give it a more hard economic edge. Part of the problem is that you're not necessarily able to put an economic value on what, say, a rainforest does for us. Not that a rainforest needs to do anything, but you know what I mean. They're actually trying to get economists to understand that there is money potentially involved. For example, fixing up I think it was a dike or something that needed to be fixed in Vietnam. If you put $1 million into it, a $7 million return in not having to be spent on fixing dikes is the money that's involved. So in some respects, it's what you don't have to spend if you remediate, say, a wetland or grasslands or something like that. It can be through filtering air pollution, pollination. Grasslands are really important for that. Climate regulation, rainforest, even simple things like creating soil. We rely on our planet to do all these things. It's a thermostat. So if we don't have all these systems in place, it's not going to work, and that's the problem. They think that any number of these, and I actually got a bunch of the numbers here, and I'm going to read them to make sure I don't get them wrong, can be expressed in terms of per hectare. It's often a lot easier to do it that way. A coral reef, for example, tropical and subtropical, can range between $14 and $1.195 million per hectare per year.
Wow.
And this can have key values along the lines of tourism, storm protection for coasts. That's extremely important because they effectively act as like a barrier. They actually soften the blow coming onto the coast. And also they're really important fish nurseries. So if you don't have them, well, you can think, well, it's not going to make that much of a difference. But when it comes to, say, how much the coast is going to get battered by storms, because storms are getting worse because, that's right, we have climate change, you can see that there's money that doesn't have to be spent there. Grasslands don't seem as though they cost that much or are worth that much, but they're actually really important for things like climate regulation and for watershed protection. Anything between $300 and $3,100 per hectare per year. And you think, well, it doesn't really sound like all that much. But being able to put a number onto it means that you can actually start working out how to incorporate it into economics. And it's trying to do in this report what the Stern report did for climate change.
Yeah.
Trying to give an edge to it so you can actually trade, if you like. They haven't put a value on the entirety of Earth's ecosystems. The authors of the article have, and they reckon that it could be around $500 billion. Doesn't seem quite enough, though, when you think about the fact that the Earth's global economy is worth $70 trillion. But then you've got to take into account that the Earth is really important for being a kind of global thermostat. If we don't have that, it doesn't work. So instead, they're trying to look at this as an indicator of the most immediate economic benefits. And again, it's a way of trying to provide another form of discussion, involvement, trying to get some value onto this so that even simple economists can understand why it's important.
But also, I guess, a way of saving the environment as well, because there's one thing that we've learnt over the past decades is that the free market will, in the end, gobble up the environment because no value has been placed on the environment. Once there's a value there and it can be traded, therefore it can also be protected as well.
That's exactly right. And it's actually trying to change the perception of the investment into the environment as actually being an investment, not just a cash cost or even being a sunk cost. Well, we've got to do this because they say we should. No, there's actually a really important return on this, that if you actually make these systems work the way they're meant to, then there's other money you don't have to spend, for example, or you can pull tourists in because you have a really amazing set of wetlands. Trying to get people to understand that the earth and the different ecosystems inside it aren't there for no reason, and they are in fact quite important, oddly enough.
Well, staying with the environment and in particular climate change, this next story, it sounds a little bit Armageddon-ish, and I don't want to sort of overstate this one, but it's all about how climate change could flatten cities. Janine.
Yeah. Let's not get too carried away with this one immediately. But it is potentially quite a serious problem because a number of volcanoes across the planet are effectively held together by a glue of permafrost and glaciers, ice. As soon as you melt them, you start losing that glue that holds them together. And it's happened once before. We know at the end of the last ice age, when it started warming up a bit, that a certain number of volcanoes lost vast amounts of material. And again, I have the numbers just to make sure I'm going to get this right. There was a volcano in Chile 11,000 years ago that a third of its volcanic cone collapsed. That equated to 10 billion square metres of rock. It covered 370 square kilometres of land, and it travelled 95 kilometres. Now, that's pretty serious stuff when you think about it, but even in the more recent past, Mount Cook, Aoraki in New Zealand, all of you would know about that. In 1991, they had a series, about a week, where it was about 8 degrees over where you would normally expect to see temperatures. 12 billion cubic metres of rock was lost from the volcano. It travelled 7.5 kilometres and reduced the height of the volcano, by 10 metres.
Was that
and
where
that's pretty serious, you think?
Yeah, was that just a bit falling off the top?
Basically, a whole bunch of the rock slipped because the permafrost and the ice, the glacier, started melting. It wasn't related to any other factors that they could pin it down to. So you could potentially start losing a whole bunch of rock near areas such as Seattle, places in the Andes. There's others around Mount Fuji. That's potentially another very bad one. The habitation around volcanoes is a lot more now than it was 10,000 years ago. So you can only think about what might happen if you have large rock slides and how far they travel. They have vast amounts of energy and a large amount of physical material. So the prospect of losing that onto a city, for example, is a bit concerning when you think about it. So once again, we have another issue where you have climate change potentially impacting the Earth in ways that no one had really foreseen before now. People are only just starting to grasp some of the potential issues that might arise from a warming planet.
But no volcanoes or mountains in Melbourne City. Janine, I think you're safe there.
No, I think we're okay. It's you lot that I'm more concerned about, the good people of New Zealand. You have a shaky couple of islands going on there, and it's not just related to earthquakes and volcanoes and stuff. You've got a lot going on over there.
Well, there was a terrible program on TV last night that tried to scare Aucklanders into the fact that there would be a possible volcano eruption, which is, as plausible, but the way that it was executed as entertainment wasn't all that great.
Did it work, though? Did it actually scare Aucklanders?
A lot of people talking about it on Twitter, but more in a jovial kind of joking about how bad that was. But yeah, it is a possibility. Rangitoto was only formed, which is it's an iconic piece of Auckland landscape. It was only formed 600 years ago, so anything can happen any time, I suppose.
Well, volcanoes go into dormancy and then they wake up, and these things can happen. So, as I said, you've got a bit going on over there at the moment. If you have massive earthquakes around Christchurch and the like, then the Earth is active. So, maybe they might not be too wide of the mark.
Indeed. Thanks very much, Janine.
See you next week.
Check out the stories in New Scientist magazine, which will be out next week, and of course also newscientist.com.